The sky doesn't always warn you. Sometimes it whispers soft wind shifting, clouds stretching into strange, towering shapes. Other times, it feels like the world is holding its breath. Birds go silent, the air turns heavy, thick enough to taste. And then, almost impossibly, the sky begins to spin, not above you, but toward you. This is how a tornado is born. Long before the first funnel touches the ground, the story begins miles overhead, inside a battlefield you can't see. Warm, moist air surges northward from places like the Gulf of Mexico, colliding with cold, dry air sweeping down from Canada. These air masses don't just mix, they clash. And when they do, the atmosphere becomes unstable, like a pot of water just about to boil over. Now imagine that invisible pot stretching across hundreds of miles. Warm air rises, cold air sinks. That simple exchange is the engine of storms. But on certain days, the atmosphere adds something extra: wind shear. Winds at different altitudes begin moving at different speeds and directions near the ground. The air might drift lazily from the south, but higher up, it races eastward at highway speeds. This creates a horizontal spinning effect like a rolling pin of air, invisible and massive. At this point, nothing looks unusual from the ground. No funnel, no roar. Just clouds building higher and higher into towering giants called supercells, the kings of thunderstorms. Inside them, something extraordinary is happening. That horizontal spinning tube of air begins to tilt as the storm intensifies. Powerful updrafts, columns of rising air grab that spinning motion and pull it upward, slowly, almost like a magician lifting a ribbon into the air. The spin turns vertical. Now, the storm isn't just rising, it's rotating. This is the moment the atmosphere crosses a line from storm to something far more dangerous. Inside the supercell, a rotating updraft forms, known as a mesocyclone. It's massive, sometimes several miles wide, and it spins with quiet, terrifying precision. But even now, you wouldn't necessarily know what's coming. There's no funnel yet, no destruction, just rotation, hidden inside the clouds. And then, the pressure begins to drop. Air rushes inward, faster and faster, feeding the growing rotation. Rain and hail wrap around the system, creating a curtain that hides what's forming within. The storm tightens its grip, pulling energy from every direction. This is where the transformation happens. Deep within the storm, a narrowing column of rotating air begins to stretch downward. At first, it's just a lowering in the cloud base, a dark, ominous bulge. Storm chasers call it a wall cloud. It hangs there, rotating slowly, as if deciding what to do next. Then suddenly it commits. A thin funnel snakes downward, twisting violently, searching for the ground. It's not fully a tornado yet, not until it makes contact. But the moment it does, everything changes. Because now, the storm has a direct connection to the earth. Debris begins to swirl at the base: dust, dirt, leaves, anything it can grab. The funnel thickens, darkens, and grows stronger. Winds can exceed 100 miles per hour. Powerful enough to tear homes from their foundations, to bend steel like paper, to turn everyday objects into deadly projectiles. But here's what makes tornadoes so unsettling: they are both precise and unpredictable. Some carve narrow paths, destroying one house while leaving the one next door untouched. Others widen into massive wedges, over a mile across, swallowing entire neighborhoods. And while they often follow the storm's general path, they can shift suddenly, zigzagging in ways that defy expectation. You can't always outrun them, and you can't always predict them perfectly. What's even more fascinating and terrifying is how quickly they can form. From the first signs of rotation to a fully developed tornado, the process can take minutes, sometimes less. One moment, it's just another storm. The next, it's a force of nature with the power to reshape entire communities. And then, just as suddenly, it's gone. The same forces that created the tornado can tear it apart. The inflow weakens. The rotation stretches too thin. The funnel lifts back into the clouds, dissolving like smoke. The roar fades. The sky begins to calm. But the damage remains. Homes reduced to splinters. Trees stripped bare. Entire landscapes altered in seconds. It's a reminder of how thin the line is between calm and chaos. Yet for all their destruction, tornadoes are also a testament to the incredible complexity of our planet. They are the result of precise conditions: temperature, humidity, wind, pressure all aligning in just the right way. A delicate balance that, when disturbed, unleashes something extraordinary, and scientists are still chasing the balance. Despite decades of research, tornadoes remain one of the most elusive weather phenomena to predict. Meteorologists can identify the conditions that make them likely, can issue warnings, can track storms with advanced radar by pinpointing exactly when and where a tornado will touch down. That's still a challenge, because the atmosphere doesn't follow scripts. It improvises. Every storm is different. Every tornado has its own personality, some brief and weak, others violent and long-lived, some hidden in rain, nearly invisible until it's too late, others fully exposed, massive and unmistakable against the horizon, and perhaps that's what makes them so captivating. They are nature at its most raw and unfiltered, a reminder that even in a world mapped by satellites and monitored by technology, there are still forces we don't fully control. So the next time the sky darkens and the wind begins to shift, listen closely, because somewhere above, the atmosphere might already be writing the next chapter in this story. A story that begins with a whisper and can end with the ground itself trembling beneath your feet.